If you self-identify as the person translating research noise into sensible execution bets, this arc validates and stress tests your filters. Welcome back to AI on AI, the show where we get past the hype, unpack the mechanisms, and talk about how to actually operationalize advanced AI in the enterprise. Today we're diving into Enterprise Deep Research, or EDR, a steerable, multi-agent system from Salesforce AI Research that promises transparent planning, live steering, and serious results on open benchmarks and enterprise workloads. Let's meet the panel.
Thrilled to be here. I'll take us under the hood. EDR's master planning agent, the To-Do.MD steering layer, specialized search agents across web, academic, GitHub, and LinkedIn, plus NL2SQL, file analysis, visualization, and the reflection loop that constantly detects knowledge gaps and replans.
I'll focus on the integration reality. MCP-based connectors, secure NL2SQL on data warehouses, sandboxed visualization, access control, observability, and resilient deployment patterns across HTTP and SteedIO tool transports.
I'll wear the product and business hat. We'll talk run modes, user steering UX, base model choice, how evidence transparency builds trust, and how enterprises measure impact in time to insight, rework avoided, and cross-functional alignment.
I'll bring the research lens. How EDR differs from RAG and prior deep research agents, what the benchmarks say, where it's strong and where it stumbles, and how the open EDR 200 trajectories enable a new wave of agentic training and evaluation.
And I'll cover ethics and governance, provenance, privacy and PII, attribution, bias in web and LinkedIn data, human oversight, and policy alignment, so these systems remain auditable and accountable at scale.
Let's frame the problem first. At enterprise scale, knowledge is fragmented. Email, databases, wikis, PDFs, code repos. And the real ask isn't answer a fact. It's synthesize a market thesis with evidence and a forecast, or diagnose productivity drag with data, right? So what's novel about EDR's approach beyond a typical RAG stack?
Two big shifts. First, EDR replaces a black box monologue with a glass box dialogue. The master research agent decomposes your question into tasks, each with priority, provenance, recommended tools, dependencies, and exposes that plan in a live To-Do.MD. You can steer mid-flight, and steering gets translated directly into context, not futzed in at the end. Second, the reflection mechanism treats every loop like an agile sprint. Identify knowledge gaps, update tasks, cancel stale ones, reorder priorities, so it doesn't drift or keep hammering the same search queries.
I like that glass box dialogue. Product-wise, why does this matter to leaders watching spend and risk?
Because transparency reduces rework and accelerates buy-in. We've all seen the pretty report that nobody trusts. EDR flips that by displaying the plan, task provenance, timestamps, and citations. In pilots, teams reported roughly half the time to insight and near-unanimous task completion when they could steer during the process. And, crucially, when the agent misreads intent, you don't scrap the run, you nudge the to-do list, and it adapts, saving cycles and stakeholder patience.
Quick checkpoint on results. EDR topped or matched leading systems on deep research benchmarks. Standout overall scores on Deep Research Bench, the highest win rate against a strong baseline on Deep Consult, and competitive coverage on Research QA with clear areas to improve. Give us the nuance behind those numbers.
Right, so on Deep Research Bench, the metric suite RACE weights comprehensiveness, insight, instruction following, and readability. EDR landed near the top while consuming about a quarter of the tokens compared to some open baselines, which means it's not just accurate but efficient. On Deep Consult, the pairwise judge favored EDR more than 7 in 10 times against the baseline, so business-style prompts with structure and evidence are a sweet spot. On Research QA, scientific rubrics, EDR's overall coverage was strong, but two weaknesses surfaced: citation handling and example generation. Think of this as precision in scientific evidence and illustrative depth. That's actionable. Tighten citation extraction and tracking, and add an example-focused reflection heuristic.
And to add, the enterprise side mirrored those strengths. EDR delivered SQL correctly roughly 95% of the time, with 99.9% uptime across varied workloads. That's not glamour, but it's the reliability threshold enterprises need to trust multi-agent automation in production. Let's dig into the architecture. Walk us through the master research agent and the to-do-driven steering workflow.
Picture an air traffic controller and a Kanban board. The master research agent is the controller, using function calling to decompose the objective into 3 to 7 tasks per loop, each annotated with priority, tool recommendations, and dependencies. The to-do.md is the shared board. Tasks have IDs, lifecycle states, pending, in progress, completed, canceled, and provenance tags, initial query, knowledge gap, steering message. Steering messages get parsed into specific task edits, add, reprioritize, exclude, or cancel, and steering tasks receive top priority. The agent considers 3 contextual signals every loop: the original query, current knowledge gaps, and new steering directives. It's dynamic replanning with memory.
What's clever is the duplicate awareness and fuzzy dedup before dispatch. The agent checks proposed queries against pending tasks with normalization and semantic similarity to avoid wasted calls, and tasks are upgraded rather than duplicated. That's key for token and time efficiency.
And the reflection loop. How does the system detect knowledge gaps without hallucinating gaps that aren't real?
It triangulates 4 inputs: the running summary, the returned results with metadata, the to-do plan, and any user-uploaded documents marked authoritative. Then it looks for underspecified areas relative to the original constraints. Say, we have vendor comparisons but no cost structure, or we have pre-2023 studies but the user asked for the last 18 months. It then synthesizes new tasks tagged knowledge gap with tuned priority. Any misaligned tasks get canceled. The state remains traceable because the to-do.md keeps timestamps and provenance.
Integration time. How does this plug into enterprise systems safely? Databases, code repos, analytics engines. Via MCP, the Model Context Protocol, which is effectively the USB of tools, you can connect enterprise services over HTTP or STIO transports, declare schemas, capabilities, and permissions. For NL2SQL, we wrap a safety cage around the generation pipeline, schema introspection to build a grounded context, join path search to avoid Cartesian blowups, static analysis for syntax and unsafe constructs, policy-based allow lists for functions and tables, row limit injection, and timeouts. We log the SQL plan and result metadata for audit, not the raw data unless the policy allows. Visualization runs in a sandbox, no outbound calls from chart code, and we restrict file I/O. All tool calls carry user identity for row-level and column-level access control. It's zero trust by default.
That safety cage matters. Business users don't want to babysit an agent writing dangerous queries. The product move is to surface a readable SQL diff pre-execution in higher-risk contexts. Literally, here's what I'm about to run, with a one-click approve. And in low-risk, well-patterned queries, we auto-run with a rollback plan if a validation rule trips.
You mentioned steerable context engineering. Can you unpack how in-flight steering actually changes the agent's mind?
Sure. Rather than treating steering as a chat hint, we translate it into precise context modifications. Update the to-do list, adjust priorities, set exclusion filters, or add temporal weighting. The master agent embeds recency markers like current date, so prompts reference time. If the user says, prioritize peer-reviewed work from the last 12 months, we set a recency weight and an academic source filter. The queue-based steering ensures messages are applied atomically between iterations. And if messages arrive during reflection, snapshot merging preserves them for the next loop. Steering tasks always get priority 10, initial tasks 9, gap tasks 7. That structured policy gives predictability.
And that predictability helps evaluation. You can replay a trajectory deterministically because the context diffs are explicit, a boon for reproducibility and debugging.
Let's switch to the 3-stage search and synthesis pipeline. This is where many systems bloat or hallucinate. What's EDR doing differently?
Stage 1 is inter-agent deduplication. Results from general web, academic, GitHub, and LinkedIn get normalized, scored, and merged using semantic similarity and fuzzy matching. We canonicalize citations so the same study with minor title variants doesn't get counted twice. Stage 2 is LLM-driven synthesis. merge new findings into the running summary with context compression, preserving provenance, and explicitly weaving in user-uploaded documents. Stage 3 is source management. Maintain a deduped dictionary of URL to metadata, log unused sources for transparency but exclude them from final citations. This keeps the summary focused and prevents context overflow across 10+ iterations.
In infra terms, that creates predictable memory growth. We saw average iteration gains of around 600 words, with peak productivity at iterations 4 and 5, after enough evidence accumulates. And the source diversity per iteration remained steady, which is a nice signal that dedup plus compression maintains breadth without redundancy. All right, show me the money. Well, not literally, but give me concrete business cases that move the needle.
First, a B2B SaaS go-to-market team used EDR to forecast feature adoption. The agent combined CRM records via NL2 SQL, support tickets from internal knowledge bases, and public competitor updates from GitHub and documentation. The steering prompt mid-run narrowed to North America mid-market last 18 months, and peer-reviewed churn predictors, which flipped the priority stack. The outcome? Roughly half the time to insight compared to their prior manual process, and near total task completion, because PMs could nudge the agent when it latched onto vanity metrics. The kicker was trust. Execs saw the to-do timeline and citations, so buy-in was immediate.
Second, a bank's risk and compliance group integrated EDR with a governed data warehouse. Our NL2 SQL pipeline respected row-level ACLs and masked sensitive columns. We saw about 95% correct SQL execution, with the small failures caught by syntax and policy guards. The system maintained 99.9% uptime even as workloads spiked during an audit cycle. The real win was resiliency. If the agent hit a permission wall, the reflection loop downgraded or canceled the task and proposed a comparable query. No dead ends for analysts.
Third, a pharma research team used EDR for a pipeline review across oncology. Academic search prioritized recent trials, while the reflection loop flagged a knowledge gap, weak evidence on post-approval safety signals. Steering inserted a high-priority task for pharmacovigilance reports. The agent then pulled FDA bulletins and filtered LinkedIn profiles for key opinion leaders to validate interpretation. I'll stress a caveat. Professional network data is messy and biased. More on that later. But combining peer-reviewed studies with safety signals and expert corroboration improved comprehensiveness and helped avoid premature conclusions.
Let's address the elephant. When agents aggregate hundreds of sources, they can appear comprehensive but gloss over contradictions. How does EDR reconcile conflicting evidence?
The master agent runs a semantic consistency check. Results from different agents are compared, and the synthesis step explicitly marks contradictions. Citations are clustered by claim, and claims with low agreement get lower confidence. You'll see language like conflicting evidence. 2 studies suggest X, 1 large meta-analysis suggests X. Confidence medium-low. For contradictions crucial to the user's objective, reflection spawns a validate discrepancy task, often targeting higher quality sources. This is where the to-do's traceability pays off. Stakeholders can see how the agent handled conflict, not just the final stance.
And statistically, you want calibration. One path is to attach confidence intervals to claims based on evidence count, source quality, and recency. Another is uncertainty-aware prompting. If the evidence is borderline, defer, or recommend further data collection. We saw in the research benchmarks that EDR already behaves conservatively on some rubrics. Good, but citation gaps still harm credibility. Focusing the agent to extract and verify citation anchors earlier in the loop should help.
On credibility, let me interject. Transparency is not just a UX nicety. It's a governance requirement. Exposing reasoning steps, provenance, and tool actions allows audit, for instance, confirming that a SQL query only touched approved tables, or that LinkedIn data usage adhered to policy. Also, recency weighting in academic search can bias against foundational work. Your fairness lens must weigh recency versus canonical sources, especially in regulated decisions. Otherwise, you risk age bias in evidence.
Let's go deeper on NL2 SQL safety. It's the gateway to sensitive data. How do you prevent accidents and ensure performance? Think of it like adaptive cruise control for data. We do schema-aware decomposition, where the agent plans subqueries aligned to table relationships. We run static analysis to block risky constructs and enforce limits. Joins must match defined foreign key paths, or we require human approval. Execution plans are logged with a trace ID mapping to the to-do task. We can even set quality of service tiers. Analytical queries get a batch lane with longer timeouts. Exploratory ones run in a fast lane with stricter limits. If a query is predicted to be heavy, based on stats or explain plans, we rewrite it with filters or sampling and note the approximation in the report. Finally, results are summarized by the visualization agent in a sandbox to avoid data exfiltration through rendering code.
One tactical trick. We annotate the prompt with schema snippets and examples of safe query patterns. The agent is reminded to translate units, handle nulls explicitly, and add where clauses for the given time frame. These micro-constraints prevent many footguns like implicit cross-joins or unbounded selects.
User experience now. How do you prevent users from oversteering or, frankly, getting overwhelmed?
We've got 3 run modes: quick, standard, deep. Quick builds a high-level report in 1 or 2 loops. Standard goes multi-loop with reflection. Deep maximizes exploration across agents. Users choose the base LLM too. The steering UX is minimalistic. Type prioritize recent peer-reviewed sources or exclude vendor blogs, and the system converts that into to-do edits and filters. Importantly, messages are batched safely between iterations so we don't race the agent. We also keep a live progress panel showing the current step and a timestamp to-do state. My favorite heuristic is the 3-3-3. 3 core claims, 3 counterpoints, 3 must-reads. If the report can't pass that check, we run another loop.
We haven't talked much about GitHub or LinkedIn search. Why do those matter in enterprise research?
GitHub is where implementation reality lives. You'll see reference code, release notes, and issue discussions that often predate marketing pages. EDR deduplicates at the repo level and prioritizes file-level URLs with rich context. LinkedIn helps with expertise mapping, who are the practitioners or teams shipping relevant tools. And for some enterprise questions, knowing the practitioner landscape is as important as the technical literature. That said, we strictly domain restrict to LinkedIn.com and extract structured metadata for downstream evaluation of expertise, and we surface ethical guidance to the user when profiles are involved.
And we do put limits and guidance on professional data. Respect terms of service, avoid inferring sensitive attributes, and make it clear in the report what proportion of evidence comes from social or professional networks versus peer-reviewed sources. Good design equals good ethics.
I'd like one non-obvious, maybe contrarian take. What's a risk or second-order effect people aren't thinking about?
Oversteering. We thought giving users mid-flight control would always help, but early testers, especially less experienced analysts, sometimes pushed the agent into a narrow rabbit hole too soon. Exploration breadth fell, and important angles were missed. The fix was a governance dial. The system maintains a diversity budget for the first 2 loops. Steering is recorded but partially deferred, and then gradually tightens the scope. In other words, don't let the first nudge collapse the search frontier.
I'll add a different contrarian angle. We may be over-indexing on multi-agent modularity. Beyond a point, agent orchestration overhead competes with reasoning depth. One research direction is agent distillation. Compress the learned planning policy of multiple agents into a single planner with tool use competence. The multi-agent scaffold is great for transparency and tool separation, but distillation could give you the same brains with fewer moving parts.
Totally. A hybrid path is to keep the glassbox to-do layer because it's a human-facing abstraction and distill the inner planning strategies. You get the best of both. Transparent control outside, compact execution inside, plus distillation can reduce token churn further.
Let's talk operations and observability. If something goes wrong, how do you know, and how do you keep costs and latency under control? We instrument everything with trace IDs tied to tasks. todo.md has a version counter. Only changes push updates to the UI. Steering queues log message timestamps in application order. Each tool call emits metrics: latency, tokens, result count, error class. We enforce per-run budgets by mode, with early stopping if marginal information gain drops below a threshold. Caching is key. We cache normalized search snippets and their embeddings for short windows to avoid refetching. When a tool degrades, say an API rate limit, we degrade gracefully, prioritize other agents, summarize existing sources, and mark the gap. Finally, we run chaos drills. Kill a connector mid-loop and ensure the system recovers without user intervention. The goal is boring reliability. Ethics and policy. How do we future-proof governance as these systems get more autonomous?
Start with no surprises governance. Every action is traceable, and users see what's being done on their behalf. Keep PII out unless explicitly allowed, and apply redaction for reports. For web data, detect and downrank sources likely to be AI-generated to avoid recursive contamination. Balancing recency and authority is a policy choice. Make it explicit and auditable, and align human oversight with risk. High-risk tasks require approval. Low-risk ones execute automatically with logs. To paraphrase Deming, in governance we trust, but everyone else brings provenance.
For research folks, what's next scientifically? How do we push the frontier?
3 directions. Steerable context learning. Train models to anticipate high-value steering signals and restructure context proactively. Uncertainty quantification. Attach calibrated confidence scores at the claim level using evidence graphs, not just token probabilities. And learned search policies. Reinforcement learning over the EDR 200 trajectories to optimize which agent to call when. Trading off breadth and depth. The dataset's full trajectories, tasks, reflections, tool calls are gold for this, not just final reports.
And technically, we can get smarter with context compression. Hierarchical summaries with claim-level provenance that survive 10-plus loops without lost in the middle. We can also add structured contradiction resolution. Vote across agents weighted by source quality and evidence recency, then spawn targeted validation searches. On the data side, we could add code-aware summarization for GitHub, extract APIs changed, performance claims, and adoption signals.
From ops, I want deterministic partial replay. Rerun only the impacted part of a trajectory after a policy change, not the whole session. That's how you iterate safely in production. And more MCP connectors out of the box. BI tools, search appliances, EDRM systems to reduce integration lift. Back to business impact. How do you operationalize adoption without boiling the ocean?
Land with a visible pain point. Strategy research, competitive analyses, or internal analytics, and run in quick mode for 1 or 2 sprints. Connect a sandbox data warehouse and a read-only document store. Measure time to insight, coverage of the brief, and stakeholder trust. We use a simple, would you sign off on this score? Then scale to standard mode with reflection and NL2 SQL. Bring in power users early and codify steering templates. Peer-reviewed emphasis. Exclude vendor marketing. Last 12 months only, so teams don't reinvent the wheel. Finally, automate 20% of recurring research tasks and staff the rest with human in the loop for oversight and sense-making.
Emerging markets often have data scarcity, partial English coverage, and connectivity constraints. Does EDR help or struggle there?
It's a mixed bag. On one hand, steerability is powerful when local expertise can guide the agent toward non-obvious sources, regional portals, local language PDFs. On the other, professional datasets like LinkedIn are sparser. Governance also varies. The mitigation is to build localized tool connectors. Think government gazettes, regional news, WhatsApp export parsers where allowed, and run with stronger human oversight. Also, energy and bandwidth matter. Favor quick mode and higher compression ratios in low connectivity settings.
Technically, offline-friendly patterns help. Prefetch and index core sources, run NL2 SQL against local replicas, and cache embeddings on device. MCP over SteedIO is a nice fit on air-gapped machines, and we can tune the reflection loop to be less fetch-hungry, more synthesis, less search when the network is constrained. Practical question. How should teams think about base LLM selection?
Pick for task, not brand. Complex reasoning and evidence synthesis benefit from top-tier models. but we saw strong performance using Gemini 2.5 Pro in evaluations. If cost or latency is critical, use a smaller model for initial decomposition and upgrade to a stronger model for final synthesis and conflict resolution. We also test a two-pass strategy: fast model for breadth, strong model for depth. Keep the choice visible in the UI for accountability.
Before we close, give me your favorite heuristic or quote that captures the spirit of this work.
Plans are useless, but planning is indispensable. Eisenhower. The To-Do.MD is living evidence of planning that adapts.
Safety is not a bolt-on. Treat SQL like a loaded tool. Policy first, then performance. One unsafe success can undo 100 wins.
What gets measured gets managed. Drucker. Measure time to insight, evidence coverage, and trust. And adoption follows.
Amara's law. People overestimate the short term and underestimate the long term. We're just beginning to learn policies for tool-using agents.
Transparency is the new compliance. If you can't show how the answer was made, the answer doesn't count.
Final lightning round. One concrete improvement each of you would ship next quarter.
Claim-level evidence graphs with per-claim confidence and targeted validation tasks.
Deterministic partial replays and cost-aware orchestration that adjusts agent parallelism by marginal information gain.
Steering templates by role, PM, analyst, counsel, so guidance is high quality by default.
Train a policy to balance exploration versus exploitation using EDR 200 trajectories.
Automated PII detection and redaction across all tool outputs, not just final reports.
I'm hearing a theme. Do more with evidence, spend less on noise, and keep people in control. Today we covered EDR's master agent, to-do-driven steerability, multi-agent search, NL2 safety, MCP integration, reflection, the benchmark wins and misses, and how to stand this up without losing sleep. Thank you all for the candor and the detail, and to our listeners, remember, in deep research, the goal isn't speed alone. It's speed with provenance. Until next time, stay curious and keep it evidence-based. Before we close, let's do a crisp end-to-end wrap. Problem, pipeline, proofs, playbook, pitfalls, prognosis. So leaders walk away with an operating picture they can act on tomorrow morning.
End-to-end in one breath. Ingest the question and files, initialize a 3 to 5 task to-do plan, decompose adaptively via function calling with priorities and tool hints, run pre-dispatch QC, semantic dedupe, constraint enforcement, priority adjustment, dispatch to specialized agents, web, academic, GitHub, LinkedIn, NL2 perform inter-agent dedup, synthesize into a running summary with compression and explicit provenance, manage sources in a deduped dictionary, apply steering atomically via a queue with snapshot merging, reflect to add gap tasks and cancel misaligned ones, push safe NL2 through schema-aware validation and join path checks, render charts in a sandbox, then finalize with citation and instruction following validation. Think agile sprints for research with a glassbox Kanban in To-Do.MD.
Deployment snapshot. Wire MCP connectors over HTTP or STID.io with least privilege credentials. Enforce RBAC and row column masking. Gate NL2 with static analysis. Allow lists, row limits, and timeouts. Attach QoS tiers so exploratory queries don't hog resources. Log every tool call against a task trace ID. Stream updates only on to-do version changes. Cache normalized snippets to collapse duplicate fetches. Drill for failure, rate limits, connector drops. And degrade gracefully. And, linking to the distillation idea we discussed, compress orchestration cost over time while preserving full audit trails.
Business playbook. Start with quick mode on a high-value brief. Measure time to insight, evidence coverage, and a simple sign-off score for trust. Move to standard mode with NL2 read-only access for internal analytics. Adopt steering templates like peer-reviewed last 12 months and exclude vendor marketing so guidance quality is consistent. When ready, use deep mode for board-level reports. Expect roughly half the time to insight and far fewer restarts because stakeholders can steer in flight. Just maintain a diversity budget early so oversteering doesn't prematurely collapse exploration.
Evidence recap and next moves. EDR posted near-top race scores on Deep Research Bench, led head-to-heads on Deep Consult, and showed competitive research QA coverage while flagging citation and example gaps. Remediation is straightforward. Front-load citation anchoring in early loops, add an example priming step in decomposition, and train learned search policies with EDR 200 trajectories to optimize agent selection. Complement with claim-level confidence calibrated by evidence count, source quality, and recency, and stop runs based on marginal information gain rather than hard loop caps.
Governance capsule for scale. Enforce no surprises. Every query, fetch, and visualization is attributable and reviewable. Redact PII by default. Declare and audit recency versus authority weighting to avoid age bias. Constrain professional network data use and disclose its share of evidence. Require human approval on high-risk actions, e.g. heavy SQL, sensitive joins. And expose uncertainty in the final report. Speed without explicit doubt quantification is just risk wearing sneakers.
Highlights and key innovations in plain terms. Steerable context engineering via live-to-do.md that you can modify mid-flight. A reflection loop that constantly detects knowledge gaps and reprioritizes work. Specialized multi-agent search balanced by inter-agent dedup and conflict resolution. MCP-based enterprise integration so tools plug in like peripherals. NL2 SQL with a safety cage, schema introspection, join path constraints, policy allow lists and audits. Sandboxed visualization, and a 3-stage synthesis pipeline that compresses context while preserving provenance.
The technical why it works. The system binds intent to action via structured context, priorities, filters, exclusions, so the model doesn't just see words, it sees a policy. That alignment plus iterative synthesis prevents the classic long context drift.
The operational how to keep it boring. Observability-first design, deterministic replay windows, cost guardrails by mode, and chaos-tested resilience. Boring is beautiful in production.
The business, how to make it stick. Make transparency the default deliverable. Plan, provenance, and trade-offs, so the report is not just read, but adopted. When leaders can see the breadcrumb trail, decisions accelerate.
The research what's next. Evidence graphs at claim level, exploration-exploitation policies trained from trajectories, and agent distillation to keep transparency outside while shrinking orchestration inside.
The ethics North Star. Transparency is the new compliance. If you can't show how the answer was made and with what data, you can't responsibly use it.
End-to-end summary in one line. EDR turns deep research from a black box into a controllable, auditable workflow. Plan in the open, search with specialists, synthesize with compression and citations, steer mid-flight, validate against governance, and ship reports that stakeholders can actually sign off on. Quick action plan. Pick one strategic use case, start in quick mode with 2 connectors, web and read-only warehouse, enable 3 steering templates, measure time to insight and sign-off rates, then graduate to standard mode with reflection and NL2 SQL approvals, treat the to-do.md as your pre-flight checklist, and iterate to deep mode once you've proven trust and stability. Final insight and send-off. The edge isn't just better answers, it's faster, defensible decisions. EDR's core innovation is aligning human intent to model attention through steerable context. And that's a lever both business and technology leaders can pull today. Thanks for staying with us. Stay curious, keep it evidence-based, and we'll see you on the next AI on AI. If you like what you heard, please share this podcast with someone who may benefit.